What is up, everyone? How are we all doing? So just starting everything, just starting it over. Just starting it over. Okay. Just going over the stream, guys. One sec. Just trying to, get everything on the way. Get the stream going. Now, how does one see a live stream on YouTube? Can't remember. Live stream on YouTube. Where am I? Come on. Surely it's here. No. Your channel. Oh yeah, it's here. Learning Rustlings. No. Okay. Sorry guys, I know you guys can only see my face right now. But we'll get on the way in just a second. Just 1 second. Okay, very cool. Okay, with anyone here, we are going to just get started then. So we are carrying on with Rustlings. Let me just double check. You can see that? Yeah, you can see that. All right, learning Rust. So we are in Rustlings. Okay, let's go into there. Let's do this. Zoom in so you guys can kind of see well. Okay, well, if I remember right, if I go into Rustlings and I just go Rustlings Watch, we have quite a few exercises kind of just working. Or we have functions for not working. Rust Analyzer is on. I think, yeah, you don't need this. You actually put the arrow in before, right? This is the syntax. Yeah, it's the, yeah, it's like the function, declaration, arrows, boolean, and then this. Okay, I think that's all good. Where are we? We're in structs now. Structs. 1 second. So if we see the into exercises, no. Actually, we don't want to see the into exercise because then Rust Analyzer gets confused. Structs. What is going on? See the exercises. See the structs. Huh. Oh, it's just it's being loaded. Okay. Okay. Here we go. This looks nice. A little bit of padding from the left side. Hey, Anna James, 56. How are you doing? First time tuning in. Nice. Thank you for coming. Hope you enjoy the stream. Over on Twitch. Not much. Just doing some programming. If that's your thing, feel free to stay. But yeah, just trying to learn the Rust programming language. I gotta introduce people. It's kind of a low-level language. Not really a low-level language, but like a very fast language with some very interesting types that I've wanted to learn for a little while. So now I'm just walking through exercises and getting through it, hopefully learning together. Pretty cool. How are you doing today? Not bad, not bad. Doing okay. Doing okay. How'd you find the stream? You just tuned into software engineering? Is that? I hope that's what I'm streaming. Yeah, software and game design. That's good. How are you? Where are you chatting from? Let's wait until the reply. Well, let's think that over. Let's start with one of the exercises. So we have a struct. Address all the to-dos to make this work. Okay, so we have a color classic struct, and we have a color struct tuple. It's color tuple struct even. I'm browsing software games and I saw your stream. Oh yeah, nice. Thank you for tuning in. I've got a couple of people. I'm from Texas. What about you? Oh, cool. It must be around 2 o'clock for you. I'm from the UK, near London. Not quite in London, but near London. Yeah, it's around 9 o'clock for me. All right, well, hope you enjoy the stream. Anything, let me know. All right, what have we got here? So we have some structs, color classic struct, and they want green dot red, green blue. Okay, so basically they want red. I think a U. Is it a U8? I think it is a U8. Some mash you can do. U8, red, green, blue. Oh, it wants a comma. Okay. And this is U8, U8, U8 if it wants this. So let green is equal to color classic struct. Red is 0. Green is 255 and blue is 0. And where we can do the same. Oh, what was that? We can do the same thing here with the color tuple struct, if I remember right. 02550. And what is this? Instantiate a unit like a struct. Is it just this? Okay. What do we have? Failed with try again. Here's the output success. Okay, fail the unit struct. Standard out. Oh, how does one do that? Oh, not here. Let's go here. Rust learning the book. This is the book. We need structs. Unit. A unit like structs. Surely we can do this with the tuple types as well. Oh, unit like structs right there. Great. So cool. Right. We're done here. What do we got in chat? Good, nice to meet you. I'm enjoying it already. You're learning programming or you have some experiences? I have a fair bit of experience. I work as a software engineer professionally. I've done for a few years. Also graduated. I graduated last year, so it's been a year and a bit since I graduated. So yeah, been programming for a long time, since I can't remember, to be honest, like 13, 14 years old. Just a long time, and been programming seriously, I would say, since I was like 18, 19. And professionally for about 2 years. Yeah, cool. How about yourself? How what's going on in Texas? You in college, high school, work? What's up? Yeah, I'll let you reply. And then okay, now that we have this one done, let's go on to the next one. What do we have here? Okay, address all the to-dos. So we have an order. We have a create order function that returns an order. And we have tests. And we have a test. So basically, we have the order template to do create your order using templates using the update syntax. Okay, so so the order template returns this. So this is order with the spread of order underscore template. And what do we want? Name which is string from hacker in Rust. Communities come after base struct. Dot. No. Yeah. Oh, okay. So I put it like at the end, like so. A semicolon here. What else do we want? So it wants name. Yeah, to be the same. So basically everything except count as well. Count's gonna be 1. And I think we're done. I am not done. You are done. Alright, let's see. We're working on when I was satisfied fresh and doing this for about 5 years. Oh, nice. Pretty cool. Digital art, it like I guess I'm showing a bit of ignorance here, like studio cartoon stuff or more corporate art, or something I just missed completely. But that's really cool. My partner, she's also very artsy. She is a silversmith, which is kind of very different, but she used to do a lot of digital art as well, which is quite cool. Alright, let's keep going. So we have one more file here. Structs contain data, but you can also have logic. In this exercise we have defined the package struct. Yeah, the package struct, and we want to test some logic attached to it, make the code compile. So we're implementing in package a function new with the sender country to string, receiver country weight in grams, U32. This is not how you should handle errors in Rust, but we will learn about error handling later. Okay, so we just panic. Great. Okay, this means we just kind of return from the function. This takes in self, and it returns, I believe, package, right? Is international. Actually, this is a boolean, right? It returns self dot sender country is equal to self dot receiver country. I think that's how you, well, I hope that's how you compare strings. Get fees, and the fees could be 132, I reckon. So we can do return self dot weight in grams times cents per gram. What's going on? Create international. Oh, it's the opposite. It's yeah, not equal to. Okay. Nice one. WOMP is good. Like streaming stuff and stuff out approaching 3D models. Oh, that's really cool. Well, I hope you enjoy the stream. I hope you're into programming a little bit. At least that's all I'm going to be doing today. But yeah, thank you so much for joining. It's been it's great to have someone view, I suppose. Should we see any stats? What are the stats? Yeah, we have the one view on Twitch, which is, yeah. Thank you for following, by the way. I should probably put alerts on for that. And what do we have on YouTube? One viewer, which I very much suspect is myself. Yeah, pretty cool. Yeah, really nice. Okay, Rustlings. Let's see, what do we have? We have to enums next. So we're about a third of the way through, which isn't that reassuring. But we can power through. We can power through to define a few types of message below. Okay, so basically we want to go quit. We want echo move, comma, comma, move, and change color. Is that right? Cool. What's up? Enums 2, 2 and 3. Define different variants used below. All right, let's do some Vim. Let's do some Vim. let's do some macros. So let's find this, go back, delete 0, back tab, go forward 1 twice, delete, and hopefully I can just do that 3 times. There we go. Oh, it actually chopped off a bit at the end. Echo, change color, quit. Okay, good enough. Oh, and the move should take into U8, I guess. And the change color should take in 3 of them. U8. Missing struct fields for move. Does that know how you do that? Oh, and an echo has a string. I guess we can go struct position, which is x u8, y u8. Oh, but this wouldn't really work. Okay, let's see in the Rust book what we have. We have enum. So yeah, we can send in string. We can send in like tuple like this. We can embed a struct, or we can just do it directly. So instead of that, we can just go x u8, y u8, and we should be good to go. Nice. I subscribed to the channel, by the way. Oh, thank you so much. The YouTube channel. Or which channel? Oh, on YouTube. Oh yeah, I see that. Nope, that's not you. I am useless at this still. To YouTube, I assume, not Twitch, because that would be too kind. Wow, I actually can't see anything. Am I missing something? Alerts. Maybe I need to go here. Oh no, I just, okay, I'm getting into weird territory right now. Anyways, sorry, fairly new to the whole Twitch thing, Twitch and streaming thing. Having lots of fun, but yeah, still a bit confusing. Okay, let's go to the next exercise. So, address all the to-do. So message, is it still the same thing? It wants the same messages. So let's just take these, go to the next one, paste them in. Okay, we have point, we have state. Oh, the move is now a point, okay. Yeah, and where do you come in? So state, oh yeah, implement the change color, this, process, to do, create a match expressions, process different messages. So if we go match message, and we can tell Rust LSP to do this for us, which is really nice. Oh, and it wants okay, so the move is going to have the point, and it's going to have self dot move position. That's going to take in the point. Echo, that's going to take in a message, and it's going to do self dot echo message. The change column RGB self dot change column RGB, and then the quit, which is just going to be self dot quit. Okay, what is it telling us? Pretty nice. Oh, by the way, would you like to have a look at my work? I'll show you, by the way. Yeah, of course. Go ahead. Just post it into the chat. I'll have a look. Sure, add me on Discord. Yeah, I'll do after the stream. I don't really want to open Discord right now because I'm pretty sure I'll dox someone. Yeah, cool. I'll just save your message. Yeah, it would be nice. Let me take a look. Okay, next up. Strings. 1, 2, 3, 4. Here we are. Okay, make me compile without changing the function signature. Isn't this just a string from? So it is. Alright, next we have make me compile without changing function. Try not change this line. Word is gonna take in not string but a borrowed so a reference to string. And then here you're gonna give reference. So that now ownership is preserved. Oh no. No. Thank you, Rio. Thank you, Rio's brother Henry. That's something. How do I delete a message? It's pretty funny. No, I'm not gonna do that. Actually, you get programming content. Unlucky. Right. Super distracted right now. What am I doing? To do remove white space from both ends of the string. Yeah, I mean this is just input dot what is this? This is Is this? No, it's not going to be input dot string. This is going to mutate. Return a string slice with leading trail space. To owned. I'm not sure about that. Compose me. Add the word world to the end of the string. There's multiple ways of doing this. Yeah. So there's going to be input dot. Yeah. So chat is still that. Thank you. Thank you everyone. 4 viewers. That's not bad. I noticed that Henry, you haven't subscribed. So, you know, should get on that. So this is going to be to owned plus string from world or string. What do we have? Nope. Nope. Rest concat strings. I was here yesterday. To owned. Is that it? Oh, I can't have them. That's it, I think. Replace cars in the string with balloons. So string from input. What else do we have? Nothing else in the chat. We're gonna leave it at that, guys. No moving on. No other messages. This is great. That's what I'm gonna be looking at right at the end of the night. And where's Simba? He's still on the pillar. We'll have a Simba segment in a minute. Simba event at 10 followers. Replace from cars with balloons. Okay. Okay, so this is it. I guess we can do input trim. I wonder what this must yeah. This must mutate, not mutate, copy memory. Okay. Yeah. Okay. Here are a bunch of values. Some are strings, some are references to strings. Your task is to call one of these two functions on each value, depending on what you think each value is. And to what? Your task is to call one of these two functions. Oh, right. So string slice. Yeah. Red.toStrings is string. Kind of just going to, nope. Just do that 6 times without, okay, that's you. This is the string. This is the string. This is string slice. I'm pretty sure this is format, and format returns, I think, string. String from A to Z. This is definitely string slice. Oh, that. Okay, so it is a slice. The trim returns a string slice as well. This returns, I believe, a string. Depends on the signature of replace. Yes, it does a string. 2 lowercase, I think, is a string slice. No, it's not. It's a string. Okay, we got all of them right except one at the end. Ban him, lol. No, he's okay. He's just a funny guy. Okay, we are nearly 50% there. We're on to some more interesting stuff. Modules. 1, 2, 3. Don't let anybody else have this module seat. So for this, it would probably be useful to do something really boring and reading this chapter of the book. And in doing so, completely just tank my audience. Oh, we're down to 1. That makes sense, I guess. Okay. What about YouTube? Anything else? No. Fair enough. This is not quite for everyone. All right. Okay, really big, boring bit to read now. Managing growing projects with packages, crates, and modules. As you write large programs, organizing your code will become increasingly important. By grouping related functionality, separating code into distinct features, you'll clarify where to find code that implements the particular feature and where to go and change how the feature works. Oh, it's so boring. All right. The program we've written so far have been in one module. For files project grows, you should organize. Yep. So you should organize in multiple files. Yeah, package can contain multiple binary crates and optionally one library crate. As a package grows, you can expand parts into separate crates that become external dependencies. This package covers all the techniques. For a very large project comprising a set of interrelated packages that evolve together, Cargo provides workspaces, which we'll cover in Cargo Workspaces in Chapter 14. We'll also discuss encapsulating implementation details, which let you use recode at a higher level. Once you've implemented an operation that the code can call your code via its public interface without having to know how it's implemented work. Yeah, private, public, that's very standard stuff. The way you write code defines which parts are public for that code and which parts are private implementation details that you reserve the right to change. This is another way to limit the amount of detail you have to keep in your head. A related concept is scope. The nested context in which a code is written has set of numbers that are defined in scope. When reading, writing, and compiling code, programmers and compilers need to know whether a particular name in a particular spot refers to a variable function struct in a module constraint, or other item that the item means. You can create scopes and change which names are in and out of scope. You can't have two items with the same name. The same scope tools are able to resolve name conflicts. Rust has a number of features that allow you to manage your code's organization, including... Okay, so we skipped all that boring stuff. Right. So, I mean, we have packages, a cargo feature that lets you build, test, and share crates. We have crates, a tree of modules that produce a library of executables. Modules and use let you control the organizational scope, paths, a way of naming an item such as struct, function, or module. All right. Oh, this is boring. Yep, so we have packages and crates. Okay, defining module to control. Okay, so we have a cheat sheet. So here we provide a quick reference on how modules, paths, and use keyword and a pub keyword works in the compiler and how most developers organize their code. We'll be going through an example of each of these rules throughout this chapter, but this is a great place to refer to remind yourself how they work. Start from crate root. When compiling a crate, the compiler first looks at the crate root file, usually source lib.rs for a library or source main rs for a binary crate for code to compile. Declaring modules in the crate root file, you can declare new modules. Say you declare a garden module with mod garden. The compiler will look for the modules code in these places. Declaring modules. In the crate root file, you can declare new modules. Say you declare a garden module, module garden. The compiler will look for modules code in these places. In line, within the curly braces. In the file source garden, in the file source garden mod.rs. Declaring submodules. Yep. Paths to code. Yep. I mean, this is, so if we use create garden vegetable asparagus in the public module of garden function, let's plant asparagus, I'm going. Yeah, I guess so. This looks fine. Group and loader code and modules, yep. So we have this module, for example. Okay, this is very boring. Very, very boring. Very boring stuff. Alright, anyways. What am I doing? Don't let anyone outside this module see this. But we do want the make sausage, so do pub function. Yeah. Okay, so that's what the little colon syntax is. We have mod sausage factory. This is the public stuff. Okay. You can bring module paths into scope and provide new names for them using the use or an as keyword. Fix the use elements to make this code compile. So the module's delicious snacks does self fruit pair as what? Fruit. Veggie. I guess no. Pub constant pair. Apples. Oh, okay, and it has. Okay, fruit and veggies. Not sure what is wrong with these here. What is this? So this is pub. So we make these public. Yeah. And what? Constraint veggie is private. Well, not anymore. The delicious snack module is trying to present an external interface that is different than its internal structure, like fruits and veg modules. Complete the use statement to fit the use in main. This is weird. Or is this do I need to do this to bring them into scope? Or down here? No. Fruit, pear. So confused right now. Anyways, let's look at the answers. Rustlings. Answers. Because I'm not actually sure what that one is. Okay. So this is modules. Modules what? 2. Where are we? Modules 2. Oh my god, there's so many things to do still. Okay. Public use as fruit and veggie. But I don't really understand what this is doing. Like, I get it, but... Okay. Okay, modules. So you can use the use keyword to bring module paths from modules from anywhere, and especially from Rust standard library, into your scope, bringing system time in Unix. So we can get rid of that for now. So we can import this. And we can import system time. Yeah, this is, I mean, really nice with the LSP. So pretty cool. We make the use standard time. We can actually, I think it's probably autocompletes as well for us. So we have, how many things we have in standard? A lot of things. Okay. Hash maps. Okay. So we have a function called fruit basket returns a hash map between a string and a u32. Declare your hash map here. Hash map. New. That seems about right. We insert string from 2 to, and is already given to you. To do put more fruit in the basket. So it wants you want 5, right? So, and then it does the generic there. Okay, so pretty cool. So it wants to be 5, so we can do basket dot, how many things do we have? Methods, not snippets. There's too many snippets here. Into, yeah, we have a bunch of stuff. So we can do a string from apple. Really, we only need 3 more, and then this should be enough. Expected, oh, and then just basket at the end. It says fail basket dot length. Oh, it if we do 2 here and then do orange 1, then this will work. Yeah. Okay. Oh no, that's a lot of text. We're collecting different fruits to bake a delicious fruit cake. For this, we have a basket which will represent in the form of a hash map. The key represents the name of each fruit we collect, and the value represents how many of the particular fruits we have collected. 3 types of fruits: apple, mango, and leeches. Already in the what are you? I'm afraid to Google this, but I'm doing it. Oh, strange strawberry. Oh, where am I? See next. See. Oh, hash maps 2. Already in the basket, you must add more fruit so that there's at least 1 of each kind, and more than 11 in total. Okay, for fruit in, so we get a vector of these for fruit, and you are a fruit. To do, insert new fruits if they are not already present in the basket. So we go basket dot insert. The key is fruit 1. Is that what it wanted? You must add fruit to the basket that there is at least one of each kind and more than 11 in total. So I mean, this already has this here. Can I just, if I did 10 there, so all of them have 10. Task given fruit are not modified. Oh, right, I see. So if basket dot contains the key fruit, then we continue. Yeah. Otherwise, we go and insert 10. Sure. Yes, so we do the contains key there. Hash maps 3. A list of scores, 1 per line, of these soccer matches. Given each line is the form team 1, comma, team 2, comma, yeah, so England, France 4-2. You have to build a score table containing the name of the team, goals each team scored. One approach to build a score table is to use a hash map solution. It's partially written. Make me pass the tests. So we have team, goals scored and goals conceded. The name of the team is the key and its associate struct is the value. So, okay. So if we go per line, we split in comma and we do a collect again. So vector, yep, this, populate score table. So scores dot insert. The key is going to be a string and it's going to be the what should it be? Because I mean, how do we keep information between? I mean, I think I know what this wants. Let's see. So if they do this, what are they going to expect? Oh, we're going to go through each one and okay. Okay, so we're gonna go if scores dot contains the key, and the key is a string, so if it contains the team underscore 1 name, it goes scores dot, oh actually I think we can go let existing score equals scores dot get, and this is an option, very nice, team underscore 1 name, do a comma, yeah, we lend that value and we go match existing score, nope, and we fill those in, so some team, here what we do is we go and say scores dots insert team underscore 1 name and team goals scored, team dot goals scored plus team underscore 1 underscore score, goals conceded, which is team dot goals conceded plus team underscore 2 underscore score. None, then we just do scores dot insert this, but we don't add, we just have it here. Okay, get rid of you. What does it want? The comma there? Oh, no comma there, just that there. Okay. Keep in mind that goals scored by team 1 will be the number of goals conceded by team 2. Similarly, goals scored by team 2 will be the number of goals conceded by team 1. Okay. Validate underscore team underscore score underscore 2. So we fail here. Okay. So we have to we have to do this for the other team as well. Right, teams go to name team, so we're gonna go insert 2, replace you with 2, replace you with 2, and replace you with 2. No? Aha. So, yep. So, but in here, team goals scored plus 2 goals conceded. This is actually this and this here. Nice. Okay, so we just we needed to the goals conceded is from the other team, not our existing team. Match 3 done. Options. 1. Nope, not you. What is this? Options. Here we go. What do we have in chat? Yeah. Okay. I've enjoyed your stream very well. There's a different vibe. Unfortunately, I've got to go. I have some jobs to do. Right, yeah, thank you for tuning in. Alright guys, just sending some messages. Alright. How are we doing on streams? We have 1 viewer, which I have a strong suspicion is wrong. Okay. Okay, let's keep going. Where are we? So we are doing options. 51% there, guys. Okay, we'll finish this tonight. This function returns how much ice cream there is left in the fridge. If the time is before 10 p.m. Okay. If time of day is less than 23, then if time is before 22, there are pieces left. Sum, and it's going to be 5. Going to return 5, otherwise, else, none. Or without that there. Expected option found integer. Wait, isn't that right? What else do I want? Oh. Maybe ice cream. Do you fix test how to get the value contained in the option? I mean, you can do unwrap, but that seems dangerous. So it is. Oh wait, if it's before 10 p.m. the 5 is less than at 10 p.m. someone needs more is none left. Okay. Oh, okay, actually, yeah, we go if time of day is bigger than 24. No, bigger than 23 even. We return none. This is the only time we return. If it's before this, then none. Or is this actually sum 0? So at 9, yep, 10, 23. Sum 0, 22. Is it less than 22 then? Yeah. Got it. Okay, to make this an if statement whose value is sum. What does it mean here? Oh, if optional target, then... Oh, okay, so you probably implement some trait that makes you able to do that. Okay, I think that's okay. Make this while... To make this a while let statement, remember that vector.pop while. So let integer and also let word. What is this? While that's not right, doesn't look right. If option actually want to look at this because this is strange. I'll show what the syntax is. If let's oh, we have Simba crying. Hold on. You guys can't really see, but maybe you can hear it. Listen. Hey boy, Simba, you okay? Are you dreaming? Come here. Come over here. Oh, you're very cute. Come on, come here. Come here, boy. Come on. Doesn't want to. He's very sleepy. Yeah, he was dreaming. He was just dreaming, kind of huffing in his sleep. Oh. Back to Rust. Okay, so it's if let some word, but I don't really. What is this? It optional target. Oh, this is an if statement that lets. Okay, so if lets some word equals optional target, and then word is the thing that's populated, right? I understand now. And then the other one is while. You're right, I'm kind of misunderstanding. So while let some integer equals this. While let some integer? What is that about? So integer is an option. And then this returns an option. So I need to I need to wrap it. This is so I need to return this pop returns an integer. An option with an integer. I wonder why this alone doesn't work. Integer gives option. Okay. That's cool. That's kind of strange syntax, to be honest. I don't know if I would use that. Okay. What do we have here? Fix without deleting this line. Without deleting this line. None. This is an option point that is sum and then the point inside. We match on Y. If sum, we print the coordinates. Use of partial moved value. Is it some reference to P? No. What's this about? I don't. Is it just getting rid of? I don't understand. Huh? Yeah, but that's all that options is, no? None, and then some. Right. So why do I need to make this an underscore there? I don't. There's something else to play. Oh, is it the borrowed value of Y matching the borrowed value of Y so that it doesn't go into here and then out of scope in this branch? Wow, that's something. Oh, options 3. Errors 1, 2, 3, 4, 5, and 6. Oh, wow. Okay. This function refuses to generate text to be printed on a name tag. If you pass it an empty string, this function refuses to generate text to be printed on a name tag. Pass an empty string. It'd be nice if it explained what the problem was instead of just something returned none. Thankfully, Rust has a similar construct options. Yeah. Which is the error handling. Error handling here. So it's the recoverable with result. Yes, result. Okay. So we have an option. Yeah, it returns none. Oh, and it so it wants me to change this to be a result, right? And returns an error. Yeah. String cannot be empty. Oh, actually, let's yank inside there. 22 inside here. Name was empty. Result dot into. There you go. What's wrong with that? Not sum. This is result. Yeah. Oh no, it's okay. Yeah. Great. Okay. Oh my god. Say we're writing a game where you can buy items and token all item costs 5 tokens when you make a purchase. Is a process if you have 1, a player of this game will type in how many items they want to buy, and this total cost function calculates the total. Since player typed in a quantity though, it is a string and they might have typed anything, not just numbers. Right now the function isn't able to handle errors at all. Okay, if we call the total cost function on a string that is not a number, that function will return a pass int error. Okay. Anything else? Oh, we got someone in chat. Hello, sorry for bothering you. I want to offer promotion to your channel. No, I'm okay. Thank you for stopping by though. Hope you enjoyed the stream. Okay. So, total cost returns this. And I need to return an error. What we want to do is if the... Okay, so yeah, we pass. And this returns quantity. and we actually match on qty with OK. qty, just quantity return quantity. Oh, this is actually, yeah, return OK quantity. Or is this an if let? Like if let error quantity parse error equals qty. Is it something like this actually? Return parse score error. Just do this even. Otherwise we could do the OK. And the parse error is going to be the error. No. This is annoying. This is annoying because the syntax is kind of skipping me. Does it want a match? Oh, it's this question mark syntax, right? It's like it's like zig. If I write a question mark, used in question mark, it's branch to decide whether the operator should produce a value because it's returned continue or control flow break. Right, I understand. Yeah, this question mark, if it returns an error, it's going to throw up that error. I get it now. I get what the question mark is. It's the same thing as Zig's. It's very similar to Zig's try. Like, you know, try and it puts the errors upwards. Very, very similar. Errors 3. Okay. What else do we have? This is a program that is trying to use a completed version of the total cost function from the previous exercise. It's not working though. Why not? What should we do to fix it? So we have tokens, pretend user inputs 8, does the total cost, and it will return kind of an error from here. I can't do this. This function doesn't return anything, so I can't do that. So I have to do cost. So I wonder what it actually wants from here, to be honest. We can go match cost, let the LSP do stuff for us, and we can panic with a value. If it's okay, then we go ahead and do this, and this is tokens. Wait. Oh, cost. Yeah, I'm shadowing the wrong thing. So it wants me to panic differently. It wants me to go like this. Okay. Nice. I'm not sure I like that code. It's a bit too nested for me. But yeah. Errors for the RS. Whoa, interesting. Whatever this is. So we have an enum creation error. We have a struct positive non-zero integer. Positive non-zero integer. What are we? We have one viewer. Whoever you are, thank you. Okay, this implements new with value as for a result. Why is this always returning an OK? Oh, because it needs to say. Wait, we can do this. We can just cast between types or rename an import. As unknown as any. Okay, I mean fair enough. If value is less than 0, then error, creation error negative. Else if value is equal to, actually we can do a match on value. Rust match integers range, pattern syntax 1 to sum 51 or 2 1 dot dot equals. Rust match negative number, help matching a negative number. Dot 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 is not syntax. Is it dot dot equals dot dot 0, non-inclusive? Then this returns creation error negative 0, creation error 0, everything else okay. Positive integer with value, which is still an I, but you can now cast it safely across, hopefully. Exclusive range syntax is experimental. Equal -1. Oh, it needs to put there, yeah. Love it. The compiler just knows. The compiler knows. Nice, so dot dot equals -1. Great. Okay. This is a program that is trying to use a completed version of the total cost function. It's not working though, why not? So we have tokens, pretend user. Oh, this is not the correct one. Errors 5. Oh my god. Okay, this exercise uses some concepts that we won't get to until later in the course, like box, heap allocation from, I don't know. It's not important to understand them right now. For now, think of the box type as I want anything that does question mark type. Dynamic. Rust's usual standards for runtime safety should strike you as somewhat lenient. Okay, update the return of the main to make this compile. So we want a dimensional result, not a trait. Anything with implementer. See, I'm not actually sure here because I'm not sure where the name of the implementation is. So it is error. So because it does implement error for creation error, which we did up there, and we have these here. So it is basically with anything that has this interface. Then dynamic. Dynamic here is used to highlight call to methods on the associate trait dynamically dispatched to use the trait. This way it must be object safe. Unlike generic parameters or implement trait, the compiler does not know the concrete type that is being passed. That is, the type has been erased. As such, dynamic trait contains 2 pointers. One pointer that goes to the data, another pointer that goes to a map of method calls to function pointers known as virtual method tables or vtables. Ah, yeah, that's how a lot of languages do generics, as far as I know. Okay. Using catch-all error types like box, dynamic error isn't recommended for library code, where callers might want to make decisions based on the error content. Instead of printing it out or propagating it further, here we define a custom error type to make it possible for callers to decide what to do. Okay. So we have pass positive non-zero. So we have this is enum creation error, pass int. Okay. Okay, so we implement here, add another error conversion function below. Okay, so we have from pass int the error is creation error. Parse, and it returns pass int error. Pass int error. So I mean, this looks okay. Oh, actually, creation error, pass int error, and this is going to be a parse non-zero error. So this is like a factory. So we pass in the errors that go inside, and we wrap those errors, I think. And then to change this to return an appropriate error instead of panicking. Okay, so we pass. Can I do question mark? Is that allowed? Equals match on pass, and we can fill the arm. So if it's error, if it's okay, then I think we can just do this. New positive non-zero integer U64 map error. What is map error? Oh yeah, it does it if there is an error, then we go here. If there's an error, then we return error. Oh, and this has to return okay. This returns the error of E. This is not from creation. Is this from parse? Yeah. Oh, this is actually if E dot from nope. Hold on. It's not this, and it's not this. We actually want to do something clever here. So what do we want? So we want to try and pass. If that's okay, then it goes okay. It does positive non-zero integer, and it does new x. Okay, and then it maps the error to from creation. The error is here, creation error negative or 0. If the pass fails, we actually want to return this type, this error type, parse pause non-zero error, parse int E, and E is a parse int error, yeah. I think you're correct, but what is going on here? So new x, new takes in I64, yeah. Yeah, that's good. That's fine. What's that about? Expected I64 found result. Oh, do I not? I don't need to wrap it in that. And I don't think I need to wrap you in here then, because parse int already returns an error. Or does it not? Maps the error, and then we do unwrap? No. Mm-hmm. Okay, you know what? I'm gonna cheat again, but only because I'm very curious. So yeah, we did that fine. So we pass. Oh, we just question mark. We pass. We map the error if there is one. And then we question mark. None of this weirdness stuff. None of this strange stuff. Okay. X, which is an I64, it's going to be equal to this. We map the error and we do a question mark. So basically we're going to say that if new, which returns a result, returns an error, we map the error. This function can be used to pass through a successful result while handling an error. Yeah, we handle the error here, which into this function does the creation error, puts the wraps kind of the error nice and neat there, and then it returns it upwards, like it breaks the flow of this. And then here we're guaranteed to know that that works just fine. Then we can go. That's in case of a parse error. Then we go x new, no, positive non-zero integer new from x dot map the error into the parse pos non-negative 0, and this is not from creation, this is from, oh, this isn't from wait, which is yeah, I was gonna say this is from parse int, and then this is from creation, and we do a question mark here as well. No, we don't, because we can just return straight away. And what are you complaining about? From parse. I mean, from parse is the same thing. Okay. Pretty curious by that. I'm not sure what's going on. I mean, the only thing that changed was literally the type, right? Like the name, they had from parse, like they wrote from parse here. Okay, let's have a look at this question mark. Incompatible types. Expected the I64. Oh, wait. Yeah, no, this doesn't go here. This is yeah, I'm thinking about this a bit wrong. So this is going to be s.parse. And then it maps the string where it throws up. Yeah, that's the one. I was well confused there. Okay, let's just reiterate what this does. This is not that straightforward. So first of all, we pass the string into an I64. If it doesn't work, we map the error into this function from parse int. We take the error in and we wrap it in our enum, and we say that this was a parse int error with the error containing here. Okay, that's thrown upwards with the question mark syntax. Well, it's returned from the function. It's just a nice shortcut. Otherwise, we're going to return this positive non-zero integer. We're going to take it from new. We're going to map the error. If something happens in there, we're going to do from creation. Okay, that's errors. Cool. How are we doing? 60%. We have 40% to go. How's everyone doing? We're going back into Facecam for a bit. Nothing else in chat from what I see. How many viewers have got on Twitch? You got 1. I don't know how many we have on YouTube. Oh, it says we have 2 on YouTube. Hey, YouTube guys. Oh no, still only 1. Never mind. Camera quality is not that great, is it? Yeah, the light is a bit leaves a bit to be desired. But anyways. All right. Let's go back to the stream. I feel like I need to take a break. It's been a little while. It's been a little while since I've just kind of chatted into the void. All right, just gonna go check my phone, see if anyone's messaged me. Okay. Hi, Simba. Are you okay? Alright guys, let's continue. Is everything okay with the stream? Yeah, looks like it. Generics. Okay, the shopping list program isn't compiling. It's not compiling, it's going to be a vector of string. No. Vector of borrowed, like, strings. Generics 2. This powerful wrapper provides the ability to store a positive integer value, rewriting it using generics. It supports wrapping any type. Execute Rustlings, hint generics, yeah. So we have a wrapper, has value. If we have new, it returns self, which is the wrapper of the value. It is, however, not compiling. What does it want? Provides the ability to store a positive integer. A positive integer value. Rewrite it using generics that it supports wrapping any. Oh, this I definitely need the Rust book for. Generics. Tell me about generics. Okay, so this is going to be borrowed from type T. No. Yeah, so it is T. And I feel like is this the same thing as like JS? Yes, it is. Wraps any value, self, returns self with the generic T. No. And it wraps the value. Oh, takes it in there. Value of T. You might be missing a type parameter to implement TT. That doesn't look right, does it? Oh god, come on, what's the syntax? Okay. Oh, so it is both. So we implement T and then T here. Self and returns a pointer to T. No, it's not a reference to T. It's just self. Yeah, like so. Mismatch types value parameter T. Is it just value T then? And I'm overcomplicating things. Yeah. So value T goes into value, and that should allow for any type. Oh, traits. Trait system. Let's go. This is kind of what I wanted to look at yesterday. Okay, traits. So we have a trait called append bar, and this trait just takes in self, returns self. We implement append bar for string. So this goes, this function, append bar for string, return self dot to return self dot get John good dot push. I forget to do this. Dot to what's that value, that method to turn it into like the reference? Or is it this dot astra plus append bar dot into? Or is this it? No. Append bar implement what does it want? So full bar, is it just bar? Nice. Okay, so how did this call? So yeah, we're implementing string, and now over here we should have append bar because it's implemented in this scope. Nice. Cool. Okay, then we have some more append bar. Just one sec. Your task is to implement the trait append bar for vector strings. Implement append bar for vector vec of string. Is this how it works? For stra in self dot iterator. Now string, yeah, it's gonna be, that's it. And what do I do here? Can I mutate in place? Not sure. String dot can I take in mutable? And then I can go string dot string dot push. Maybe I don't even need that. So string dot push the character, which is string dot actually we're gonna push bar dot chars and then do dot dot beforehand and return string. What's going on here? Actually just return self. Was it like this? How does one do this? Traits 2. What's the syntax for? Also, I'm not quite sure what they want. Self.push. Oh, we're pushing. Right, never mind. Okay. We're doing, never mind. Self.push. We're not mutating everything. And then Yeah, it's just self. Yeah, okay, I way overcomplicated that one. Your task is to implement license trait for both structures and have them return the same permission without writing the same function twice. Don't edit this line, don't edit this line. What is this? What is the error? Not all trait items implemented. Oh, but it said don't edit this line. Or is it just like, I think oh, what is this? There's probably something in the book about this. Traits defining shared behavior. Default implementation. So, okay, so we can go up here and actually write out a function. And then it works. So what does it want? Returns what does it return? License info, some information. Oh, okay, so string from some information. So this is the default implementation. Great, that is cool. So it's almost like inheritance, but a little bit better and only on one level. Okay. Some information, not two string. I guess that's another way of doing it. We have two structs, unit like structs, but not actually unit like, not unit structs. You may only change the next line. Compared to 2. Okay. Is this licensed? We can pass in the trait like this. Licensed. Basically, it only knows that. Yeah, so it's the dynamic value of licensed. Anything that implements licensed. Wait, just to double check, that is what it wants me to do. This traits 4. It wants a generic. Impl. So implement software is something that implements license, something that implements license. I'm not so not even quite sure about that one actually. So impl. So I mean it starts way further up here. And traits as parameters. Okay, yeah, this is what we were looking for. Now that you know how to define and implement traits, we can explore how to use traits to define functions that accept any different types. We'll use summary traits, so we can have notify an item that implements summary. To do this, we use implement traits. Instead of concrete types for the item parameters, we specify the impl keywords and the trait name. This parameter accepts any type that implements a specific trait. Nice. Yes, this is like an interface. It's passing the interface, not a concrete value. Okay. And what's our progress? We're getting there. But I think I'll call it after this trait stuff. I'm getting pretty tired and would like some rest. Your task is to replace question marks. You may only change the next line. So, okay. So what do we have? We have a trait, some trait that has a function returns true. We have other trait returns another function, other function that returns true. Some struct, other struct. We implement some trait for some struct and other trait for some struct. And so it's, yeah, we implement everything for everything. And we have some function that returns an item that's that implements both Declare a trait bounds. Okay. Specify multiple trait bounds with the plus syntax. So basically we need some, so that implements some trait plus other trait. There you go. So it needs to implement both. Pretty cool. It's nice syntax. What's quiz 3 looking like? Okay. Last one. We'll do quiz 3. This quiz tests generics and traits. An imaginary magical school has a report card generation system written in Rust. No wonder it's imaginary, huh? Currently the system only supports creating report cards where the student's grade is represented numerically, so 1 through to 5.5. However, the school also issues alphabetical grades A+ and F-, all the way to F-, and needs to be able to print both. Make the necessary code changes in the struct report card. Okay. So the grade is either F32 or a string. Okay. So it's basically a generic that can only be 2 types. Generic that can only be 2 types. Generics. Validating references with lifetimes. Oh, I'm actually super curious about this. We'll come back to this. Curious. But we need generics, right? We need generics that can be specific. That can either be one or the other. So maybe that's not what I want at all. Hint, hint. To find the best solution to this challenge, you're going to need to think back to your knowledge, especially the trait bound syntax. So this is going to be standard. So this is going to be display. Okay. Doesn't have a known size of compile time. No, I'm not going to get there. This is too. So it is a generic. Okay. So it's just a generic, and I probably need to go further down, and I noticed that there's 2 things here. A report card that is a F32. Actually, it doesn't need that because it's just defined by that. F64 even. Report card F21. Make sure to change this grade. Oh, to finish the exercise. Okay, what's going on? Implement print. Implement this. Do you also need this? So we're implementing in report card that takes in these generics. And then we need to go like implement standard FMT display. Let's do a use of that. Here we go. We're going to implement display for report card T. What is that? So, oh, so this is like some form of narrowing. I'm not even sure what this syntax is actually. Yeah, not sure about the syntax. Is there a T with a colon? yeah, what is this? So, no, not really. Okay. Generate the alphabetical report. Okay, so this is an A+, right? Great. And I am done. Now, lifetimes are going to be interesting, but I actually need to do some reading on that. Alright guys, thank you so much for tuning into the stream. How long have we been live? An hour and 40 minutes. Nearly 2 hours. It's been a while. This stuff's tiring, you know? Like, you don't quite realize, but yeah, streaming is... Like videos in general, you have to keep talking and yeah. Still check the chat. Is there anything else? No, no one else in the chat. Alright guys, thank you so much for watching. I'll catch you in the next one.